In this video, we're going to do regressions using a TI graphing calculator. Now, while my emulator is a TI 84 plus, if you have a TI 83 plus, it definitely works in the same venue as well. So again, we're going to check out examples 4, 5, and 6 from our 9.5 organizer. If you are interested in looking at Desmos regressions, if that's your calculator you're going to use most often, go back and watch the video on the previous slide. And I would also suggest, for the TI for the TI regressions, check out these first 3 and then go back and look at regressions 1, 2, and 3 to do those on the TI calculator and see if you agree with the values that come out with the Desmos regression. So let's check out problems 4, 5, and 6. So when you do regressions on a calculator, we want to make sure that we're using an appropriate equation. So the first thing we're going to do is actually turn on diagnostics. And this means we're going to have an extra value, r squared, down below our regression equation once we figure that out. That will tell us how appropriate our equation is for our data. So to get there, hit your second button and then go to catalog, so 0. And we're looking for diagnostic on, which we could scroll all the way down to look at our Ds, or if you'll notice in the top right corner, I have a little A, that's the alpha lock. So that means I could actually hit the button that has D right above it, which is actually x to the -1. And that will pop me right down to the Ds on here. So now I don't have quite so far to go down to find my diagnostic on. So hit enter and then enter again. It will say done when it turns it on. Alrighty. Next step is we need to enter our data. So in problem 4, we're looking at the age of a baby alligator in months versus the length of the baby alligator. So to put in our data, go to stat and then hit enter for edit. And we're going to put data in L1 and L2. Now you'll notice I already have data in there. So to clear that out, I can actually put an arrow up to the L1 and hit clear and then enter, and that will clear out my entire list. So notice I hit the clear button. If I hit delete, this is what happens. The list is gone. So if you do that by accident, you can actually insert your L2 list again, hit second, and then right over delete or the DEL key, you see INS for insert. It'll insert a new space, and then I just need to type in L1, which I can find right above the 1 key. I need to hit the second button. So you'll notice it changes to the arrow instead of the alpha lock. And then 1 for I want L2. So let me delete that. Second L2. And it even brings back the data that I had in there. So again, to clear out a list, when you're up on the name, just hit clear and then enter. So now let's enter our data that we have in the first chart. So we had, for our X's, our top row, we had a 0, a 1, 2, 3, 4, 5, 6. Alrighty, and then I'm going to hit the arrow to go over to the next column, which is where I'm going to put my Y data, my length of the baby alligator in inches. And this is where you want to double check, make sure that you're accurately typing in. Because if you lose a decimal place or you don't type in all of your values, then your list will not match up and you will not have an accurate regression that's being done. So you'll notice I did not get in my extra keys. So we're on line 5, which is 27.5. Come on. Sorry, with the emulator on the computer, it doesn't always register as quickly as a real life calculator. Alrighty, so there's my list entered. So now I need to figure out the regression type. Now we're really just deciding between 2 regression types, excuse me, either quadratic or exponential. So quad or log. So let's run both of them and see which one comes up the best. So we're going to go to stat again. And then if you hit arrow, you'll go to calc. And so these are all the different things that you can run on the statistics that we put into our L1 and L2 columns. We're going to do a quadratic regression first. And so we're going to choose quad reg and we hit enter. Now you could absolutely just hit enter and it'll run your regression for you. However, I'm going to kill 2 birds with 1 stone here. So if I add in a few extra variables, it will actually save the equation that we create and let me do predictions for, part C on our question a little bit easier. So what that means is I need to do three things. I need to tell it which two lists to look at and where to save the equation. So L1, again, is right above the 1. I have to hit the second key to get there, and then 1 for L1. Then I want to hit comma, which is right above the 7. Then I want to say L2. And again, I need my comma. And then my next thing to do is I want to say, hey, go through and solve this in the Y1 location so we could graph this out and do calculations on it. So to get my Y, I need to go to vars and then arrow over to yvars. We are trying to enter a function, so we want option 1. And then there's all of our Ys. We're just going to enter this in Y1. And now when I hit enter, it will run my regression and save my equation for me. Alrighty, so those are all the variables that I could potentially have on there. And I'm going to make a note over here. So for our quad reg, what we're looking at to determine whether or not this is a good regression is that R squared value. The closer that is to 1, the better our regression is. So if we had R squared equals 1, then our function would be a perfect fit for our data, and any predictions that we have would be spot on. They'd be exact. We have our R value of 0.993. I'm going to round to 6, which is still pretty darn good. That's really close to 1. So let's see if we get something similar for our exponential regression. So I don't have to re-enter my data. It's already saved in there. I just need to go to stat and then arrow over to calc and then just pick a different regression. So we're going to try exponential regression, which means we're looking for EXP. There he is, EXP or EG, exponential regression. So same kind of thing. I want to tell it, hey, look at L1 and L2 and save my equation. I'm going to put it in the Y2 block to help me out. So L1, L2, comma, and then vars, yvars, function. And because I don't want it to overwrite what I put in there for the quadratic function, just in case I have to decide which one I'm going to use, I'm going to put this in Y2. All right, hit enter, and same thing. It's going to spit out some expressions, and we're looking for the R squared value. Now this one, it pops up a little differently because it's a different function. But again, we're looking at that R squared value. So EXP, well, our R squared value is 0.9913. So both sets of data are actually pretty good, but the better one is actually quadratic. And so that's the regression we're going to use. And this is why I wanted to save these in 2 separate Y values. So now I don't have to rerun that regression to go look up my values. All I need to go look at is the Y equals, where it saved my equations. And that Y1 equation, that's my quadratic regression. So best regression was quadratic. That hit the data points a little bit better. And then our regression equation, our Y, is approximately equal to, I'm just going to round to 3 decimal places just to keep it pretty accurate, but still not have to write down all the digits. It's using 10 significant digits on here. So 0.047, which rounds up to 8, and that's the coefficient on my x squared, plus 0.857x, or again, coefficient to the x, and then our constant at the end is plus 21.809, or about 81. Alrighty, so there's our quadratic regression. Now we need to predict what is the length of the baby alligator at 8 months. And so because we used months in our x's, and we already plugged in our Y equals, we can actually make the calculator do the work for us. So we are going to look at a table of values to see what are all the possible values for that function. And we can only do this because we saved our equation into Y1. So I'm going to hit second and then graph. It's getting at the table. It's right above the graph button. And again, our quad reg was what we put in the first equation. So that's the table, or that's the set of Y values we're looking at. And so if I look for where x equals 8, right next to that, I have my y1, which equals 31.714. So that's how many inches long we're predicting the length of a baby alligator is at 8 months. If you want to see a picture of the data, here's what we can do. If we just go to graph, and I can't really see my data in there, and your graph probably looks different. You might have it centered with going from positive 10 to negative 10. All depends on what you used last time you looked at your calculator. So to fix the window on this is a little different from what we did on Desmos. We're going to go to Zoom. And then if you scroll down, there is an option called Zoom Stat. And what that's going to do is with the data that we entered, it will automatically set the window size so we can see the data as well as the graphs that we created. So if I hit enter for Zoom Stat, it'll automatically pop me back to the graph. Ooh, here's what happened. I turned on Zoom Stat, but I didn't tell the calculator, hey, look for actual statistics. So what I need to do is right above the y equals, you'll see stat plot. So hit second, y equals, oops, there we go. We just need to turn our stat plot on. So I'm just going to do it in the first one. Hit enter to highlight the on. And then I'm going to leave every other setting the same. So it's automatically going to plot the individual points. It has L1 and L2 already listed on there for us to get our data from. And then the mark is actually going to be a box, which will make it pop up a little bit better on the graph. Alrighty. So now that we have that set, let's go back to Zoom Stat again. So Zoom, and then Stat was option 9. Now it should work. There we go. And you'll see both of our graphs, they kind of overlap each other a little bit because both of them were pretty decent fit on there. But if you only wanted to look at one graph at a time, don't forget the way that you can turn a graph on or off. If we go back to y equals, we only use the y1 graph. That's what we were worried about. So I'm just going to move my cursor down to the second, to y equals, and hit enter. That will turn that graph off. And so then when I go back to my graph, the only thing I actually see is that quadratic graph that we chose to use. And again, I could zoom way out if I wanted to get a better picture generally of that entire function all at one go. But as long as it hits most of the points and we've got that r squared value to refer to, then I'm very confident that we have the correct value. Alrighty, so let's try this again. Problem number 5. So problem number 5, again, I need to update my data. So go back to Stat, Edit. And again, we could clear out the whole list. Probably not a bad idea. So we're going to clear. And then again, put your cursor up on the name, hit clear, and then hit enter or arrow down. It'll clear out your whole list. So our x values, first row is 0, 1, 3, 4, 6. Now I'm hitting enter after I enter each one. Okay, my y value is 1,000. And then 610, 220, 132, and 45. And again, I want to double check, make sure I had my entire list. Let's see, I left off the 0 on the 220, so I'm just going to arrow up to that one and retype it. So 2, 2, 0, enter. And now I have more accurate data. Everything looks good. So I am ready to do my regressions. So it took a while to type everything in, didn't it? So I'm going to cheat a little bit. The nice thing about a TI calculator is you can call up previous things that you typed in to, make your life a little easier. So to do that, if you notice right above your enter button, there's a blue entry. And so if we hit that, it will actually call up the previous things we typed in. So I'm going to hit second, enter. And I want to still do the quad reg first, so I'm going to do it again. So second, enter. So there's everything we typed in for quad reg. You could type it in again if you wanted to, but just make sure you have the L1, L2, and Y1 in there to ensure that we've got that saved. Alrighty, hit enter. And again, I'm going to make a note of what my r squared is. So our quad reg, which is the first one we're doing, Our R squared is 0.9936. Again, not too bad. And because we had the y1 typed in there, it automatically overwrote what we had in the y1 graph. So now let's do exponential regression. So again, hit second enter until you get the EXP popping up again. There we go. Hit enter. And for EXP, oops, there we go. Our R squared equals 0.9997. So that one's even better. So again, we're going to use our exponential regression, which is in the format y equals a times b raised to the x. And we should have automatically saved that in our y2 equation. So let's double check. So let's go to y equals. And there it is. We have 1018.28, etc., times 0.5968, etc., raised to the x. So that's our equation. So we're using the exponential. And our regression equation y was approximately equal to. And so you'll notice I'm using this terminology. It's kind of like what we have written on Desmos, if you've watched that video as well. But I do want to show that this is an approximation equation. It's not exact. So my predictions that I'm going to be doing, they're going to be pretty close if we've got an R squared value like that, but they're not necessarily exact. Okay, so y is approximately equal to 1018. Again, I'm going to go to 3 decimal places, so 284 times our b value 0.597, if I'm rounding to 3 places, raised to the x. And so that was our second equation. So that's the only one we really want to consider. So I'm going to go ahead and turn off my y1. I'm going to do zoom stat again, just to take a look at the picture to see how we did. So there's our data. There's our exponential graph. We are hitting each problem spot on. And we could have told that just by, or looked at that, or known that rather, just by saying, well, R squared was super close to 1. So part C, our prediction, predict the number of coins remaining in the 8th trial. So we want to go to our table of values and just look up when does x equal 8, but we're on our second equation. So we want to look for the y2 row before we looked at the y1. So second table, there's our 8. It doesn't even show y1 because I actually turned the graph off. So fewer things to worry about. So number of coins, we're looking at 16. Well, if you're just counting the number of coins, can you have 0.4 coins? So we're just going to truncate that to 16. Alrighty, last example. So we're going to do the same thing, enter our data, create our regression equations, and look at our R squared values to see which one's the best. Here we go. Okay, so number 6. And where do we go for our data? Stat, edit, and we want to change our list 1 and list 2. Again, I'm going to go ahead and clear out the entire list. So I have a nice empty list to start with. All of our x values, so 0, 5, 10, 15, and 20. And then our y values in list 2, we have 0.7. And you could definitely type that as 0.7. Here's what the calculator does. It doesn't worry about typing that extra 0, but it's still the same number. So we have 0.6, then we have 1.1, then 3.0, or just 3, and 4.9. Alrighty, let's check our regressions. So I always like to quit out to the main screen before I do any of my regressions. Okay, again, I could type everything all at one go. Let's go ahead and do that with QuadReg just as a reminder. So again, we go to Stat, and then Calc, and then choose QuadReg. But I need to tell it go to list 1, list 2, and save it in Y1. So second 1 for L1, comma above the 7. L2, comma above the 7. For the Y variables, go to vars, yvars, function, and we're using Y1. Hit enter to do your regression. So our QuadReg R squared equals 0.9924. Again, not bad, but let's see if exponential comes out any better. So again, I could type it all in by hand or scroll through what I previously typed in. So hit second, enter, and we'll keep scrolling back through. Every time I do that, it will go to the previous line in the history. So again, exponential regression, I'm saving it to y2 so I don't overlap my equations. R squared for exponential was 0.944, excuse me, looking at the R squared, not the plain R. And there is a difference between these, but I'm going to leave that to you. If you take statistics for your next math course, that would be something to ask your teacher about. Alrighty, so our R squared, it's okay. It is definitely not above 0.9, so that means we definitely want to go with our quad reg with what we typed in our Y1. So let's go ahead and just turn off the Y2 and look up what our values are. So again, I don't want to use the Y2, so I'm just going to turn that equation off. Let's copy down our quadratic regression. So again, we're going to use our quad reg. And our regression was that y is approximately, again, I'm just going to use 3 decimal places, so 0.015 x squared plus a negative, so that's really minus 0.093x plus 0.671. Okay, let's take a look at this picture just to make sure that everything matched up okay. So again, do zoom 9 or zoom stat. And again, definitely looks like a parabola, and it matches up really well with the parabola that our calculator came up with. And so now to look at the value, if we're going to predict ozone units at an altitude of 12 kilometers, look at your table of values, which you get to do by second graph. And so I don't see 12 on here, but if I scroll down, there's my value for 12. So our ozone units are going to be approximately 1.7823 ozone units. Alrighty, let me know if you have any questions. And again, I would highly suggest go back and do problems 1 through 3 with your calculator, and then check the filled in organizer to see, how does it compare with what you can come up with, or what we came up with on Desmos. Although if you're ready to go, keep working on this activity and then take a look at your practices for this lesson. Let me know if you have any questions.